like tears inside my face. It was like,
Oh,
yeah.
Every time that happens, I feel like my eyes look like this.
That reminds me of a funny story. When my kids were little, I used to take them to the middle school gym before school and like play with them before I take them up to the elementary school. And one time Hannah, she was like in maybe like first or second grade, and there was a goal set up. So I was like practicing. I was kicking the ball like, and she was the goalie, you know. And and one time I kicked it too hard. I wound up and like booted it, and it hit her in the face. And she hit her head on the back wall. It was like an instant thing, blood streaming down her face. I like ran over to her. I'm like, "Don't tell mom! Don't tell mom!" I think I got her ice cream after school or something, so she wouldn't tell me.
You bribed her.
Oh, now it's recording.
How old is she?
She was like second grade maybe.
Oh, goodness.
Yeah, it was horrible. I felt terrible.
Not bad enough to say anything other than don't tell mom.
It's my first concern. I don't want to get in trouble. All right. Anyway, so yesterday we talked about domain and range of functions. Any questions about that stuff? All right. So today we're going to talk about function composition. So if you have two functions, like for example, suppose you have f of x equals x plus 5, and g of x equals x squared. Okay. Function composition is just evaluating a function at another function. So for example, there's two ways of writing this notation-wise. You could write f and then a little circle in the middle of the line, g. So it's not an O, it's like more in the middle of the line like a multiplication symbol, but it's an open circle, not a dot, okay? So f composed with g of 3 or something like that. Okay, that's one way of writing it notation-wise. Another way of writing the same thing that's equivalent to it is just f of g of 3. And I think that this is a little bit less confusing way to write it, but very often, textbooks or on tests or whatever, they'll write it this way. So but my first step is always just to rewrite it this way, because I think it's less confusing. And then all you're going to do is you're just going to start from the inside and work your way out. Just like if you're doing any mathematical operations. You start with the innermost set of parentheses, and then you work your way out. That's what we're going to do here. So you're going to evaluate g of 3, which means go to the function g and substitute in x equals 3. So it's 9. So this is equal to 9. So then you just find f of 9. Okay, so this is going to be 9 plus 5, which is 14. Yeah, question? I just made it up. If this was the problem and they said find this value, then that's where the 3 came from.
So that would be the problem.
Yeah, the problem would be,
Provide a value.
it would say like find this. Like that's the given stuff right there. That's the given problem. And they'd also have to give you the functions, obviously. So if they gave you these functions and said find this, this is the process you would go through to do that. Okay? So you could actually have more than one function too, or more than two functions as well. Like if I had something like, suppose I have p of t equals 2t minus 8, q of t equals 1 minus t squared, and r of t equals t plus 3. And like that. They might say something like find q composed with r composed with p of -1. So that would be like the given information right there. Okay? And all you're going to do is you're just going to rewrite this as q of r of p of -1. And then start from the innermost set of parentheses and work your way out. So in this situation, what is p of -1? What is that equal to? -10, right. You plug -1 in for t in this function, right? And you get -10. So now we're just going to find q of r of -10. Now you go to the next set of parentheses. Oops, I missed the parentheses. Now you go to the next set of parentheses. So r of -10. What is that? -7, right? Because that's what you get when you substitute -10 in here for t. So now you're just going to evaluate q of -7. So now you plug it into this function. So it's going to be 1 minus -7 squared. So 1 minus 49 is -48. And that's the final answer, -48. That makes sense? You've definitely done this before, right? Or no?
I don't think we have, but it's really simple.
Oh, okay. Well, I thought maybe you had done it last year. Okay.
Yeah, no.
Another thing they might do is they might have you compose a function with itself. Like they might say the same, we're supposed to have the same functions here. Let me just do it over here. They might say something like find something like r composed with r of 5. And you could do that the same way, right? This is just going to be r of 5. And then start from the innermost set of parentheses. It's the same idea. So r of 5 would be 8. So now you're just doing r of 8. Okay, so r of 8 would be plugging 8 in here, so you get 11. And that's the final answer. Okay? Now, sometimes what they might do is they might actually give you a function represented another way, like a graph or an arrow diagram or a collection of points. And it's the same idea, though. You're still going to start from the innermost set of parentheses. Like if this was a graph that was given r of x, let's try it. Okay, so let's do one like that. Suppose I have a graph that's given. Here. Okay, thank you. So, maybe this isn't going to work. All right, it's hard to wait. Suppose you have a graph.
Elevator music brought to you by.
And let's say the graph of f of x is just a line segment. Okay, so let's say it's a line segment that starts right here at -2, -1, and goes to here at 1, 3. Okay, so it looks like that, right? And what's the slope of this line? I'm a little confused. It's 4/3, okay. So this is not going to be a good example. But anyway, suppose this is what the function is, and we're trying to find f composed with f of 0. Okay, this would be f of 0. And the reason why I said it's not going to be a good example is because f of 0 is not going to be like a nice, even integer number. It's going to be something weird. And this is a bad example. Instead of 0, let's have it be -1. Sorry about that. Have this be -1. Okay, so now f of -1, you're just going to look on the graph and determine what is the y value when x equals -1, right? So when x equals -1, the y value is like here somewhere. Now to figure out what that is, this is why I said it's a bad example. The slope of this line is 4/3. So if you go over 1, you're actually going up 4/3. This point actually has coordinates -1, comma 4/3, or 1/3 rather. If you're going up 4/3 from its starting point, you get 1/3. Does everybody see how I got that number? I used the slope of the line. So then this is equal to 1/3.
So what?
So now you have to find f of 1/3. So you got to go on your graph. Another example of why this is a bad problem. You go to 1/3, and you need to figure out what that y value is. All right, that's a little tougher, but you get the idea. Like if these were all integers, everything would be a little bit better. If the slope of the line was 1, for example, that would have been a better way to do it. But you get the idea. Like I could find this if it was a normal looking graph. Did I just confuse anybody, or do you understand what I'm talking about? It's still the same idea. You start from the innermost set of parentheses and you evaluate the function. It's just how you evaluate the function that varies. If it's an algebraic function, you evaluate the function just by plugging it into the equation. If it's a graphical function, you evaluate the function by finding the y value that's associated with that x value. That's the bottom line. Any questions on that? That's all homework is. It's just composing functions in that way. All right. That's it.
Isn't this our last homework for the week? Or did I imagine that? There are
Uh,
only 4 of them.
Yeah, that's the
Yeah.
last one.
It is?
Shows.
no.
Do
Isn't
we
it?
have something else?
It's the last one
Yeah,
that shows.
Oh, there should be another one. Did I mess up? Let me check.